Gosh.
Oh boy, that's going to be so cool. All right, Sophia is standing at the forward edge of the recovery zone with an update. Take it away, Sophia.
All right, thank you, Lauren. We are under 20 minutes away from EDL. That is entry, descent, and landing. And I don't think there's anyone here on planet Earth who has anticipated this day more than the principal investigator of the mission, Dante Loretta. Thank you for giving us time here today.
My pleasure. It's great to be here.
All right, so you are here on Wig Mountain because you are on the recovery team.
That's right.
Can you walk us through what you're going to be doing today?
So I'm part of the environmental sampling group. From day one, this mission has paid attention to keeping that sample pristine. And we're going to come down. We had some rain on Thursday. Most likely we're going to be encountering mud out there. We're also interested in the air quality and any water that might be standing, just so in the very rare event that any of that material somehow comes into contact with the sample, we have a record of it and it won't compromise our science.
Ah, wonderful. And I think one of the really exciting things about a mission like this, especially with you working with the University of Arizona, is that you're partnering with educational institutions. So can you talk a little bit about the legacy that a mission like this has?
Yeah, thank you. I'm a professor at the University of Arizona in the Lunar and Planetary Laboratory, and our history goes all the way back to the Apollo missions. The founder of our lab, Gerard Kuiper, mapped the moon, helped pick the Apollo landing sites and the Surveyor landing sites, and we have been involved in every major NASA planetary mission since then. And really the best part of having a university lead a program like this is that it's a great training ground for the next generation. I've been on this program almost 20 years, and I've watched multiple generations of students grow up, become professionals, either join the team. We always take our team members on board when we need to fill roles, or off into other careers in aerospace engineering, science, and many other disciplines.
It's really great to foster those incredible questions about our universe.
Absolutely.
And I know that you need to get back to your team to go on that recovery process.
The moment's almost here.
Yeah, so thank you so much for joining us, and best of luck out there today.
Thank you.
All right, back to you, Lauren.
Great, thanks, Sophia. Wow, I can't wait for Dante to get his moment in the sun.
Goes Dante.
That is amazing. All right, so Jim, the whole OSIRIS-REx spacecraft is not coming back today, right? It's
Absolutely.
just a part of it.
That's right. This is the whole spacecraft, 40 feet long, the size of a school bus. But this special little thing here, the sample return capsule, is bringing home the goodies. And that's what we've just released, and it will be entering the atmosphere, and you'll be hearing all about it. And the samples were collected at the asteroid back in October of 2020 from this TAGSAM thing that inserted them in the capsule, and the capsule was released. So that's what comes home. The rest of this goes on to Apophis.
That's right. We just heard Lori talk about that. But let's move over and take a look at this this replica SRC capsule. Now, this was an engineering model that was used in tests a few weeks ago for a drop test. Can you talk a little bit about the engineering of this?
That's right. This is a very special spacecraft, just like a small version of what we use to bring crews back when they come back home to Earth from the space station. It has a heat shield. It's about 30 inches across, so it's pretty big. It weighs over 100 pounds. Has a back shell, and inside it has the goodies, the sample return canister and the sample cap, the small sample canister. So this is the vehicle that brings those samples protected from all those changes in environment from the top of the atmosphere, 13 minutes of descent to the touchdown point that we're waiting for today. This is a very special spacecraft.
It absolutely is. And it also was used in a drop test, as I mentioned. Let's take a look at some of that footage now.
Right. So just a couple weeks ago, we dropped this replica, this engineering test unit, from 5,000 feet with a parachute deployment and went through all the operations, the choreography we need to actually make sure we can do it today. And that's what's going to be coming up. And it worked wonderfully. We inflated the big 24-foot parachute. It floated down to the surface at 11 miles an hour. We went through all the recovery operations, the safing, the bagging, and the containment to come over to the clean room here, where we'll be doing that today to make sure those samples are from Bennu, so we can study them here on Earth and not contaminated by our wonderful Earth.
That's right, and you know it's the actual SRC that they use because it is covered in dirt, as you can see
right.
on here.
This is dirt, scratch marks.
All the scratch marks, yeah.
It's a rough ride,
the real deal.
but we need it to come home. This
Absolutely.
is a real sort of homecoming.
Right. So there's a lot of science in missions like this. Not only is the SRC a treasure chest with material from the ancient solar system, but the mission itself is a platform for vital research about a range of things that you might not have expected.
SciFly's mission is to collect visual, infrared, and spectral data on spaceflight vehicles, including the OSIRIS-REx sample return capsule on its return to Earth. This gives engineers and scientists unique insight into our most challenging questions about hypersonic fluid dynamics by providing data critical to flight safety systems. The scientifically calibrated in-flight imagery team uses ground-based sensors and instruments flying on various aircraft to image asteroid sample returns, launch abort systems, parachute tests, rocket launches, and capsule returns, including Artemis 1 on both launch and reentry. The data we capture provides engineers with information on vehicle performance relative to what computational tools and wind tunnel tests predict. It takes extensive planning to get it right. Upon its return from the asteroid belt, the OSIRIS-REx capsule will be traveling at 12 kilometers per second, or about 27,000 miles per hour. That's nearly twice as fast as objects coming back from low Earth orbit, and it will be among the 4 fastest human-made objects ever to fly in Earth's atmosphere. In partnership with the Japan Aerospace Exploration Agency, Rocket Technologies International, and universities in Australia and Germany, SciFly is coordinating 3 ground stations and 4 aircraft to collect data on the sample return capsule's trajectory, heat shield performance, and the plasma environment surrounding the capsule as it speeds to the surface, all of which will help NASA understand its performance and help future planetary entry missions succeed.
Joining us now is NASA's Kate Calvin, Chief Scientist and Climate Advisor. Kate, thank you so much for being here.
Thanks for coming.
Thank you for having me.
It is wonderful to have you. All right, so as NASA's Chief Scientist, you're looking at the big picture. How much teamwork across the agency has made to, a day like today a possibility?
A mission like this takes a big team, both within NASA and without. So outside of NASA. So the mission is managed by Goddard Space Flight Center in Maryland. The sample is going to be going to the Johnson Space Center in Texas after it leaves here. Marshall Space Flight Center in Alabama does the overall program management. Outside of NASA, we have collaborations both in industry, academia, and international. So Lockheed Martin is doing built the spacecraft and doing flight ops. Kinetics is doing navigation.
Wow.
We have a science team led by the University of Arizona. And then we have
recovery operations.
Canada and Japan.
Helicopter 1 has
All of
departed
them are really
wing
critical to
to
us.
station
And
keep
I'll just stop
outside the
you right
landing
there.
ellipse.
We got a confirmation that helicopters 1 and 2 have just taken off. Very exciting. All right.
So, Kate, one other thing. As an earth science and expert on how our planet works in climate, can you tell us how this asteroid mission, the samples we return, might impact how we understand life on Earth, how it evolved, and how climate issues now might be involved?
Yeah, so this asteroid Bennu may record some of the earliest history of our solar system. So scientists are looking at it to help us understand planet formation and the origins of water and carbon, which led to life here on Earth.
That's incredible.
That is incredible. And, Kate, I know you've been to several launches. That's our typical bread and butter here at NASA. But this is more of a homecoming. How does that feel to you?
It's great. The environment here is so nice, being with the team and thinking about, this spacecraft launched 7 years ago. And now there's all this amazing science just around the corner.
Can you believe it? The team has really been working hard. And are you going to stick around for the show?
Awesome.
Fantastic. All right. Well, Kate, thank you so much for joining us.
Thank you.
Thanks, Kate, for
Wonderful.
all you do.
Thank you so much. This seems like a perfect time to dig into some more information about Bennu. Bennu isn't part of the main asteroid belt. It's a NEO, a near-Earth asteroid with an orbit that occasionally brings it in close proximity with us here on Earth. Bennu is about 500 meters in diameter, which is taller than the Empire State Building. It rotates upside down on its axis compared to Earth, with a tilt of over 177 degrees. Scientists chose to study Bennu because of its
Recovery
organic
operations. Helicopter
compounds and
2 has
mineral
departed
codes.
wing to station keep outside the landing ellipse.
All right, so you just heard that they have departed WIG. Excellent
Whoa.
progress. Fantastic. All right. Moving on, it isn't as smooth a surface as we initially thought. It's actually covered in pebbles and marked by these large rocks and boulders nearly everywhere. One boulder in particular that OSIRIS-REx had to navigate around was nicknamed Mount Doom and was the size of a 2-story building. Bennu holds the Guinness World Record of the smallest object to be orbited by a spacecraft. How fun. Now let's get an update from Sophia, who is standing on the edge of the ellipse. Take it away, Sophia.
Okay, 2 of the helicopters have already just departed, so the team is already in the recovery process, or at least the beginning phases of it. But right now, we are waiting to hear precisely where the capsule is going to land before the rest of the teams head on over to that location. Now we are about under 10 minutes away from the capsule hitting the top of our atmosphere, and we are eagerly anticipating this largest sample of ancient solar system material that we have received since the last Apollo mission in 1972. So that is 51 years since we've had such a pristine and large sample of ancient solar system material. It's a really big day for science, and we're just in the beginning phases of today, but we are certainly excited to hear about what will happen and see those parachutes finally descend through our atmosphere. So yes, we're certainly excited, but this is just one phase of this amazing mission. I'm going to send it back to you, Lauren.
See the operational milestones we're expecting throughout the morning. SRC separation already happened, and the capsule is now heading for its rendezvous with Earth's atmosphere. Jim, it always appears like these operations are simply inevitable. You know, we grabbed the sample, we flew it back to Earth, we're headed in for landing, but it's never that simple, is it?
No, not at all. And so we have a lot of critical events that take masterful engineering. We have to hit the top of the atmosphere, transition through a high G, high heat environment, go from 27,000 miles an hour down to eventually 11 for that safe landing. All these things involve changes in environments, forces, things that could disrupt our sample and change them, which we want to document. And so we really want to understand this and finally bring it to rest so we can then bag it and encapsulate it so we can eventually get the sample into our clean room here. So we're ready to transfer tomorrow to Houston to the Johnson Space Center. So this is a big process, well rehearsed by a masterful team.
Absolutely, and contains, work from thousands of individuals who are making this happen. All right, so we know that you're submitting questions from all over. Let's take a few more social questions. All right, what do we have? At Dev Saran at 5342461. What are the preliminary steps to take to test a sample? The preliminary steps.
So first thing we do is, of course, bag it here and get it into the clean room and get that sample, that sample canister inside the sample return capsule, get it under nitrogen purge, meaning we flow nitrogen gas so no Earth atmosphere and microbes get involved. That'll happen today. Period of few hours, and then tomorrow we transfer to the Johnson Space Center in Houston, Texas, where all the fun happens at the Astromaterials Curational Facility, where we've done moon rocks and samples of interplanetary dust and lots of things. Those colleagues in a special clean room perfectly designed for this mission will unpack those